For like forever, humanity has just stared up at the stars and dreamed, right? We dreamed about visiting other worlds, checking out distant galaxies, all that good stuff. But there's always been this one cosmic rule holding us back: the speed of light. Nothing, absolutely nothing, can go faster. It's the universe's ultimate speed limit, and it's kept our biggest dreams locked away in science fiction. But what if that's about to change? What if that chain is finally being cut? A wild new scientific paper just dropped, and it's talking about a new kind of warp drive. And this isn't just Star Trek fan fiction. This is a model that seems to work with the physics we actually know. A warp drive that, get this, might not need impossible to find negative energy. This idea puts faster than light travel right back on the table. But is it for real? Have we actually figured out how to travel 10 times faster than light? The answer is complicated and honestly way more exciting than a simple yes or no. So buckle up, because we're diving into the mind-bending physics of what this all really means for our future out there. Okay, so before we break the rules, we gotta understand them. And the biggest rule in the cosmos comes from Albert Einstein. His theory of special relativity is a pillar of modern physics, and it basically says that as you push something with mass closer and closer to the speed of light, the energy you need to keep pushing it skyrockets towards infinity. It's like the universe putting up a giant stop sign. And that's why even our speediest spacecraft, like the Parker Solar Probe, which hits insane speeds over 430,000 miles per hour, would still take something like 6,300 years to get to Proxima Centauri, our very next-door neighbor star system. To us, that's basically an eternity. If we're ever going to be an interstellar species, we can't just be fast. We need a cheat code. And for years, scientists have had a name for that cheat code: the warp drive. The idea isn't to blast a ship through space faster than light. That's impossible. The trick is to move space itself. Imagine you're standing on a rug. You can't run across it at light speed, but what if you could grab the rug in front of you and pull it while the rug behind you stretches out? You haven't really moved on your patch of rug, but you're suddenly on the other side of the room. That's the core idea of a warp drive. It would wrap a starship in a bubble of normal, flat spacetime. Then, it would squeeze space in front of the bubble and expand it behind. The ship inside, it wouldn't feel a thing. No crushing G-forces, because relative to its little pocket of space, it's perfectly still. But the whole bubble is moving, surfing on a wave of space-time at what could be an incredible speed. Einstein's local speed limit is still intact, but our ship just found a serious loophole. This brilliant loophole was first laid out with real math back in 1994 by a Mexican physicist named Miguel Alcubierre. His Alcubierre drive became the gold standard for warp travel theory. It proved that Einstein's own equations could, maybe, allow for this kind of cosmic surfing. It was a huge moment that yanked warp drives out of pure sci-fi and into theoretical physics. But Alcubierre's idea came with a catch, a massive, seemingly impossible catch. To get the space-time to warp just right, to get that squeeze in the front and that stretch in the back, his model needed something called negative energy density. Now, this isn't antimatter, which is totally real. This is hypothetical stuff with bizarre anti-gravity properties. It would have to have negative mass. If you tried to push it, it would come back at you. And the Alcubierre drive needed a ton of it, basically forming a shell around the work bubble. The problem? We've never, ever seen this stuff anywhere in the universe. It seems to violate some fundamental rules about how energy works. Sure, some weird quantum effects like the Casimir effect can create tiny, localized pockets of negative energy density, but that's a whole different galaxy from the stable, large-scale amount you'd need to build an actual warp drive. For almost 30 years, that one requirement was the wall. The math for a warp drive worked, but the fuel it needed was, for all we knew, fairy dust. It was a cool thought experiment, but for most physicists, that's where the story ended. But what if that fatal flaw wasn't so fatal? This is where the story takes a crazy turn. A team of scientists, including guys like Jared Fuchs and Christopher Helmerich from the think tank Applied Physics, looked at the whole problem again. Their work, published in the peer-reviewed journal Classical and Quantum Gravity, asked a revolutionary question: do we really need negative energy? Their answer has sent some serious shockwaves through the physics community. They developed what they called the first general model for a physical warp drive that works using only positive energy, the normal kind of energy that makes up you, me, and the stars. Jared Fuchs, the lead author, said, "This study changes the conversation about warp drives. We've shown that warp drives might not be relegated to science fiction." So how'd they pull it off? They didn't break Einstein's theory. They found a clever new way to use it. Their new models show that with a very sophisticated shell of regular, stable matter, you can generate powerful enough gravitational fields to create a warp bubble that moves. To figure out the ridiculously complex math, the team even built a new software tool they call the Warp Factory. It's like a virtual test bed for designing warp drives, letting them see what's actually possible. And their results were stunning. They successfully modeled a warp drive that moves at a constant speed and doesn't need any impossible fuel. Okay, now this is where we have to get really clear, because this is where the hype can get ahead of the science. The title of this video asks if we can go 10 times faster than light. The direct answer? No, not yet. The groundbreaking model the applied physics team built is for what's called a subluminal warp drive. That means it travels at speeds slower than the speed of light. I know what you're thinking. What's the point of a slower-than-light warp drive? If it can't break the cosmic speed limit, who cares? And that's a fair question, but it kind of misses the real breakthrough here. The biggest roadblock to a warp drive was never really the speed. It was the fundamental physics. That need for negative energy was a showstopper. This new research proves, for the first time, that the basic idea, a moving bubble of space-time, can work with ordinary matter and energy. It proves the concept isn't unphysical, which is what many scientists thought for 30 years. Think of it like this. For centuries, people dreamed of flying. Then someone proved mathematically that a fixed-wing craft could generate lift. They hadn't built a 747 yet. They hadn't even built the Wright Flyer, but they proved the fundamental principle was sound. That's the stage we're at with warp drives. These subluminal models are the proof of concept. They show the anchor of negative energy can be cut. And while they won't get us to another star system next week, they could still totally change space travel inside our own solar system, letting us get around super fast without turning the astronauts into pancakes from the acceleration. So, if this big breakthrough is for slower-than-light travel, is the dream of faster-than-light or superluminal travel dead? Not at all. In fact, this new foundation has got people even more excited to find a true FTL solution. Other physicists are already on it. Back in 2021, a physicist named Eric Lentz proposed a different kind of solution. He theorized that by using a special configuration of energy to create something called solitons, which are like stable, self-reinforcing waves, it might be possible to have a supraluminal warp bubble using only positive energy. Now, his idea is still heavily debated, but it was another sign that scientists are getting super creative about ditching the need for negative energy. The whole game has changed. For years, the conversation was stuck on "we need impossible fuel." Now, the conversation is about geometry, about clever arrangements of normal energy, and about harnessing the fabric of the universe itself. All right. This is the part of the story where we have to take a deep breath and face reality. Even with these incredible new ideas, we are not packing our bags for a trip to Alpha Centauri anytime soon. The challenges left are, and I'm not exaggerating, monumental. First up is energy. While the new models get rid of the need for exotic energy, they still need an astronomical amount of regular energy. We're talking about engineering on a scale that right now is basically magic. And that's just one problem. There are tons of others. How do you even form a warp bubble?
How do you steer it? How do you turn it off at your destination without unleashing a giant burst of deadly radiation? Some models suggest the front of the bubble would collect space dust and turn it into a death ray. Not ideal for your morning commute. And then there's the paradox problem. Some physicists worry that any faster-than-light travel could mess with causality, the whole cause and effect thing. You could, in theory, send messages back in time, creating all sorts of headaches. It's important to note, though, that these paradoxes are a problem for FTL travel, not the new subluminal drives we were talking about. So let's be crystal clear. We are not 10 or 20 years away from a prototype. We are likely centuries away, if it's even possible at all. This research isn't about engineering. It's about possibility. It's about pushing at the very edges of what the universe will let us do. So, where does that leave us? The crazy headlines might be getting ahead of themselves, but the science underneath is genuinely revolutionary. No, scientists have not built a warp drive that can travel 10 times the speed of light. But they've done something that might be even more important. They took the biggest theoretical roadblock to warp drive, the need for impossible negative energy, and showed it might have just been a problem in our own assumptions. By developing the first ever models for a warp drive built on positive energy, they've moved the whole idea from physically impossible to monumentally difficult. And I know that sounds like a small change, but in the grand story of humanity reaching for the stars, it's a giant leap. The journey is still a distant dream, but for the first time in a generation, physicists have a new map. The path ahead is unbelievably long and full of challenges we can't even imagine yet. But the dream is alive. The work has begun. And maybe, just maybe, many centuries from now, our descendants will look back at this moment as the dawn of the warp age. What do you think? Is this the first real step towards the stars? Or will warp dives always be science fiction? Let me know your thoughts in the comments below. And if you enjoyed digging into the biggest questions in science, smash that like button and be sure to subscribe and hit that notification bell so you never miss an episode where we break down the future today. Thanks for watching.